implicit differentiation. We will examine the implicit differentiation in the case of a curve, and we will state the final form, the derivative of the curve, using the rules of differentiation, and also we will find the equation of a tangent of this curve at a particular point. The formula of this curve is x cubed plus y cubed equals 9xy. To find the derivative, we differentiate both the left hand side and the right hand side as of x. So we have d upon dx of x cubed plus y cubed equals d upon dx of 9xy. And now we apply the rules of differentiation. So the left hand side becomes d upon dx of x cubed plus d upon dx of y cubed. The right hand side becomes 9, the coefficient of x times y, 9 times the derivative as of x, so dx upon dx times y, plus 9x times dy upon dx. At this point, the differentiation of y cubed follows the chain rule. Let's suppose that y cubed is a new variable z. Since y depends on x, z also implicitly depends on x. So differentiating y cubed as of x is like differentiating z as of x. But remember that z is a function of y and implicitly a function of x. So the derivative dz upon dx is dz upon dy times dy upon dx according to the chain rule. The first derivative dz as of dy becomes, becomes 3y squared. So the derivative of y cubed as of x becomes 3y squared times dy upon dx. Now we substitute this result here, and we eliminate 3 from the left hand side by dividing everything by 3. So we have x squared plus y squared dy upon dx equals 3y plus 3x dy upon dx. Rearranging the terms of the last expression and taking the derivative as common factor of these two terms, y squared and 3x, we have y squared minus 3x in brackets times dy upon dx equals 3y minus x squared, and finally we solve for the derivative dy upon dx, and becomes 3y minus x squared over y squared minus 3x, and the proof is complete. Now, for the second, find the equation of the tangent. We need first off to find the slope of the straight line that is tangent to the curve, and then the constant term. Let the general expression of the straight line be y equals m times x plus c. M is the slope, which is the first derivative at this point. So we use this formula here, and we substitute x and y. So 4 in place of x and 2 in place of y, 4 in place of y, and 2 in place of x. So we have 3 times 4 minus 2 squared over 4 squared minus 3 times 2. Finally, we get 4 out of 5 as the slope. Substituting the slope, this equation becomes 4 over 5 x plus c, and since A is also a point on the line, it means that its coordinates verify this equation. So we again substitute y and x with 4 and 2 respectively, and we solve for c. Finally, we have that c is 12 over 5. Substituting everything, the equation becomes 4 over 5x plus 12 over 5, and now we multiply by 5 to eliminate the denominator, so we have 5y equals 4x plus 12. And rearranging to obtain this form becomes minus 4x plus 5y equals 12.